So our next problem is find k closest elements. Okay, this is similar to the previous problem we have solved. So in this problem, we have given an array and given k and x. Okay, so we need to return all the elements whose are closer to this x. Okay, we need to return k elements who are closer to the x in the array. So we have given the array of 1, 2, 3, 4, 5. Okay, and we need to return the four closest elements of 3. Okay, so what we need to return? 1 is closest to 3, 2 is closest to 3, 3 is closest to 3, 4 is closest to 3. Okay, so what is the problem statement and how we can solve this? Let's discuss it. So we have given this array and x. We need to return the k closest elements. K closest elements of x from this array. From this array. Okay. So we will output k elements. K elements which are closest to x. Okay. And the array is sorted. So the array is sorted. So we can use binary search. We can use other approaches as well. But we will solve it using priority queue. Okay, how we can solve this using priority queue? So what we will do, we have this array 1, 2, 3, 4, 5. Okay, what if you take the difference of everyone from this x? Okay, so this is x equals to 3. So if you take the difference, okay, if you take the difference, it will be 3 minus 1, that will be 2. Okay, 3 minus 2 will be 1, 3 minus 3 will be 0. Okay, and we will take difference in f's value. Okay, we will not take negative. So the difference will be 3 and 4, the difference will be 1. 3 and 5, the difference is 2. Okay, because the difference will be in positive only, right? There will be no difference in negative. Okay, difference will always be in positive. So this will be the difference. Okay, now if we can store this, if somehow we can store this difference in what, either in min heap or max heap. Okay, so what we need to do, we need to find the closest element, means we need to find the minimum, we need to find the minimum difference. Okay, we can convert this problem in minimum difference from x. Okay, so if we talk about minimum, if we want to find the minimum difference, we can use max heap. Okay, we can use max heap of size k, right? We want to find the kth is closest. Okay, so we can take a max heap of size k. Why? Because we want to find the minimum difference. If we want to find the maximum difference, okay, then we can use min heap of size k. That will give me the optimal time complexity. Okay, in terms of heap. Now if we take a max heap of size k, okay, so max heap of size k is 4. Okay, the size of difference is 5, but we can store the 4 closest one. Okay, so the 4 closest one will be nothing but it will be 2, 1, 1, 0, right? These will be the 4 closest one. Okay, now we need to return what we need to return, we need to return the element. Okay, we need to return the element, not the difference. So how we can return the element? In the previous problem, what we used to do, we we want to return the element, right? We want to return the element, but on the basis of count. Okay, in previous problem we wanted to return the element but on the basis of count. Similar in this problem also, we want to return the element but on the basis of difference. Okay, so for this mapping of difference and element, what we can do, we can take a pair of these two. Okay, so in this priority queue, what we can do, we can insert along with the difference, we can insert the element also. Okay, we can insert 1 here. Okay, we can insert what, 2 here, we can insert 4 here. Okay, we can insert 3 here, like that. So how we can do using max heap, let's discuss. Okay, so we have this array, let's say 1, 2, 3, 4, 5. Okay, k is given as 4. Okay, and x is given as 3. So what I will do, first I will take a priority queue of pair which will of type int and int. Okay, and we will use this first for difference, and we will use this second for my element. Okay, and I will iterate through this array. Okay, and put pq dot push. Okay, on the basis of conditions, right? We know the conditions. If pq dot size, same conditions every time, pq dot size is less than k, then we can push pq dot push. Okay, difference and element. Okay, difference and element, difference and element. Okay, like this. Now what you can do, you can calculate the difference here. Okay, so difference will be nothing but my x minus whatever current element of array. Okay, array of current element. So take it in the abs. Okay, this will take it in a positive. Okay, it is same as like this, a minus b or b minus a. Okay, same like this. So it will take the positive value. Okay, so we'll find the difference and we'll put the difference here. We'll put the difference here and we'll put the element. Why? Because we want to return the element. Okay, now if that is not the case, we know what we want to do. Okay, we will check for top. If pq dot top, on which basis I am doing this, I am doing on the basis of difference. Okay, so I will take for first, pq dot top dot first is what? If it is greater, we are taking the max heap. Okay, so if it is greater, what I will do, I will compare my difference. Okay, I have calculated the difference. So if it is greater than difference, what I will do, I will pop it out and push this one, pair of difference comma element. Okay, so what I will do, I will take a priority queue. I will take a priority queue. Okay, and its size can be at max 4. Okay, because k is 4, and I'll put the pair. Okay, so I'll put the difference. The difference will be initially, the difference will be 3. 3 is the x minus array of I. So 3 minus 1, difference will be 2. So we'll put 2 comma and the value, it is 1. Okay, next time x is 3, array of element is 2, so 3 minus 2 is 1. So the difference will be 1, and we will put this element also, we'll put 2 also. Okay, now next time, okay, it is still smaller than 4, so I will put, so my x is 3, 3 minus this current element is 3. Okay, so the difference will be 0 and the element is 3, so I will put 0 comma 3. Okay, now next time, my x is 3 and my current element is 4. Okay, so 3 minus 4 will be minus 1, but we are storing it in abs, so it will be 1 only. Okay, 3 minus 4 will be 1 only, so it will be 1 comma my element is 4 now. Okay, now come to this. Okay, so before coming to this will be in the form of max heap. Okay, so write it in the form of max heap. So the 2 1, okay, the 2 1 will be come above. Okay, so it will be in max heap order. Let's write it in max heap order. It will be okay, common, it will be difference of 1 and element will be 4, is 1, element 2 is 0, element 3. Okay, now while inserting 5, check the difference. Okay, so the difference 3 minus 5 will be 2. Okay, and here the difference is 2, so it is not greater than difference. Okay, so we will not push this. Even if you push this, that will be same, but we will not push this. Okay, so this will remain same. Okay, now what I will do, I will iterate this priority queue, and these are our element. Okay, these are element and these are difference. So I will store this element. Okay, these are the k closest element, so I will store these elements and put it in the answer. Okay, I will traverse the priority queue. Okay, I will traverse the priority queue and I will put it in the answer. Okay, so I will pop out current element. Okay, my current element will be pq dot top dot second, because second contains the element. Okay, and I'll push it in answer. So answer dot push back, okay, current element, and that will store our answer. So our answer will have something like 1 4 2 3. Okay, now if in the problem it is given that the answer should be in sorted order, so after this sort the answer, otherwise return this only. Okay, so what we are doing, we are taking the difference. Okay, the problem states that we have given a x and we need to return the k smallest, k closest element to this. So we'll take the difference, and current element in our priority queue, and based on it we will return the answer. Okay, first we will store the elements, the k closest element in our priority queue, and then push it back in the answer. Okay, and if we need to return the answer in sorted format, we will sort this, otherwise we can return this only. Okay, now if the problem given, if we change, okay, what if I say, what if my problem is find top k farthest elements? Okay, farthest elements. So farthest elements means maximum difference, maximum difference. Okay, and if you want to find the maximum difference, you can use min heap. That will be give you optimal time. Okay, so use min heap and just change these conditions, right? Just change these conditions. This condition will change. That's it. Okay, so everything will remain same. So do this problem also. Okay, in the previous problem we have done one problem. In this problem also do farthest one also. Okay, just code it in a VS Code or any online compiler, right? In current problem we were using max heap, and in this problem we have to use mini. Okay, so just do it in homework. Okay, just do it in homework, you can easily do it, right? So this is all about this problem. Let's code it also. Okay, so let's solve this. So let's take a priority queue. Okay, I want to find the closest one, which means minimum difference. So I will take a max heap. Okay, I will take a max heap. For minimum difference, take a max heap. I will take a pair. Okay, so that I can store the difference as well as the element. Okay, so before declaring this, write here in the comment. Okay, so that you can remember. So my queue will store first difference and then my element. Now what I will do, I will iterate through the array. Okay, so let's take auto num in array. Okay, and if my pq size is less than k, then I will simply push it. Okay, pq dot push, I'll push the difference. Okay, so for that I will find the difference here. So int difference will be equals to abs of x minus num, right? So I will take difference comma element. So my element is num. Okay, rest what I can do in else part. In else part, I will compare if my pq dot top dot first is greater than my difference, then what I will do, I will pop it and pq dot push the current one. Okay, so this will be difference comma my current element is num. Okay, so if see pq dot top dot first contains the difference, so if the difference is greater but we want to find the closest, so we'll remove that and we will store this minimum difference. Okay, this is all about priority queue, and now I want to store it in answer. So let's take vector int answer of size k if you want to take the size, otherwise just take it like this. Okay, so it will be of size k, we know that. Now I will iterate through this priority queue. Okay, so while pq is doesn't empty, then what I will do, I will take current element. Current element is pq dot top dot on second. Okay, so top dot second. Don't get confused between first and second. That's why I have written it here. Okay, first contain difference, second contain element. Now I want element, okay, to store it in answer. So I will take second and I will do pq.pop. Don't forget this step. Many times we forget this, and every time it will take same object, okay, same element. So now I will push it in answer. Pq answer dot pushback. I will put current element, okay, because the answer wants the element, not the difference. Okay, now it is given that the result should also be in sorted order. Okay, so I will sort this. I will sort answer dot begin. I hope you know this, right? Answer dot end. Okay, and I will return answer. So return answer from here. Okay. Oh, okay. I missed this closer ones. Okay, and yeah, let's run this. Okay, I have done pushback. So let's remove the size. Okay, let's remove the size. Now it will work fine. Okay, now it will work fine. Otherwise, you can take the size and take one more variable of I, but just take this only. Okay, let me submit this. Okay, it is accepted. So what will be the time and space complexity? Okay, so the space complexity will be order of k for our answer and order of k for priority queue, right? And the time complexity will be order of what is now array size, ARR size. Let me write this ARR size for this one. Okay, and it will be order of this k log k for iterating the priority queue. Okay, so the problem is given that given a sorted integer array. Okay, so for sorted array this will be a huge time complexity. Okay, this is a huge time complexity, but we are solving it using priority queue, so that's why I have told this solution. Okay, otherwise you can use binary search. Okay, binary search will be most optimal. So in many problems there will be an alternative solution of priority queue. Okay, whenever there is a solution possible less than order of n, mostly, or almost equals to order of n, then we try to avoid priority queue, because in many times priority queue will take n log something. Okay, n log something. So in most of the problems there will be an alternative of priority queue, but if you know that your optimal solution will take minimum of n log n or will take some log time along with n, then you can think of priority queue. Okay, if you want to optimize your problem, if any problem can be solved in less than order of n time, then try to avoid priority queue. Okay, because it takes some time. Okay, so this is all about this problem, and I hope you understood it. See, in previous problem and in this problem, I wanted to tell you about this mapping. Okay, and even in this mapping, just take the first one. Just take the first one, which you will use for sorting. Okay, so I am storing. See, heap have some property, priority queue have some property, right? In max heap, every element will be maximum. So the maximum and minimum in min heap, every root element will be minimum. Okay, so in max heap and min heap, the property will be sort in the form of first element. Okay, so take this first element to fulfill the property of min heap or max heap. Okay, and rest second element will be, we are using it for answer only. Okay, if you don't want answer in element, then we will not take it. Okay, so we are mapping the difference with element. Okay, so I hope you understood it. So I'm again writing it. Okay, so I hope you understood these two problems. Otherwise, just go through these again. Okay, you will understood it. So this is all about this problem. Now increase the complexity, and next problem will be very important. Okay, so let's move forward to next problem.